So I will present some of the interesting astronomy news that has been published last month and this month as well. So first we start with the detection of first ever fast radio burst within the Milky Way. So just to give a brief introduction about FRBs, they are high energy radio transient burst, which is having a duration of roughly few milliseconds. But in this short time span, they produce energy equivalent to the solar energy produced in 3 days. So it's a very high energy phenomena, and it has been discovered for the first time in 2007. And the first FRB is known as the Lorimer burst. So these being such a short time scale event, they are really difficult to be detected, and also this make it very hard to pinpoint the exact location of these FRBs. So since the discovery in 2007, at least 40 FRBs, or a few more than 40, has been detected so far, and all of them being extragalactic FRBs. And the closest is roughly 490 million light years away. So the origin of FRBs is under speculation, and a lot of theories have been proposed to explain them, most of them invoking some kind of a stellar remnant, such as a neutron star or black hole, or a magnetar, which is a magnetized neutron star. So in April this year, the KIME and STARE-2 radio telescope facilities has detected a new FRB known as FRB 200428 towards the galactic center region in our Milky Way. And it has been positionally associated with the galactic magnetar SGR 1935 plus 2154. So this magnetar is located roughly 30,000 light years away from us. So simultaneously, many space telescopes and detectors have also identified X-ray bursts towards this particular magnetar. So this is pretty interesting. This is the first time when there is a multi-wavelength counterpart for the FRB simultaneously. So at least for now, we know that there is few of the FRBs being likely to have association with the magnetar. But many of the extragalactic FRBs have energy levels much greater than that of the one detected here. And few FRBs are also repetitive in nature. So we don't know really what other mechanisms could produce such radio burst, but magnetars definitely have some role in producing FRBs. The exact theoretical mechanism is still unknown, but this is a small clue towards understanding the FRBs in the future. Next is the discovery of a first Earth-sized habitable zone exoplanet discovered using TESS. So TOI 700d is one of the 3 small planets orbiting an M-type M-dwarf star, which is located at 102 light years away from us. So this has been discovered using TESS, which is Transiting Exoplanet Survey Satellite, exclusively for discovering exoplanets using transient method. So they identified this planet around the dwarf star TOI 700, and they confirmed this detection with further infrared observations. This planet is a rocky planet, and it is tidally locked with this star, which means that one of the one side of the planet is permanently facing the parent star, and the other side is always dark. So the orbit of this planet is in habitable zone of the parent star, which means that there is a possibility of finding liquid water on the surface of this planet. And also the stellar wind ram pressure and interplanetary magnetic field towards this particular planet is similar to that of Earth, which means that it's a high possibility that there is an atmosphere in this planet. But since it is tidally locked with the star, it is likely that the climatic conditions in this planet is completely different from that of Earth. So with the current facilities, astronomers are not able to study the atmosphere of this planet. But they do hope that with future advanced facilities, one day they will get more information about this atmosphere towards TOI 700D, and they can compare it with the simulations and models to get a better picture about this planet. Next is an interesting news about a early universe supermassive black hole association with a proto-galaxy cluster. So astronomers discovered a giant black hole surrounded by 6 proto-galaxies using the Very Large Telescope, which is an array of 4 telescopes in the Atacama Desert. This black hole, having a weight of roughly 1 billion solar mass, powers a quasar SDSS J1030 plus 0524. And it also has 6 proto-galaxies. So this was at an era when the universe was just 900 million years old. So this discovery is important to understand the origin of galaxy clusters and cosmic web, and also the evolution of supermassive black holes. Because one question remains that how these supermassive black holes get such an enormous amount of fuel to grow into their present size. So these galaxies are one of the faintest group of galaxies mapped so far, and this will give important information for the astronomers. Next news is about a cometary activity spotted on a distant centaur. So centaurs are minor planets in Kuiper belt or outer solar system. So their semi-major axis is between the outer planets, and they have really highly unstable orbits. So centaurs are rather a mix between asteroids and comets. So they have a rocky composition like an asteroid, but at the same time, they emit gas and vapor in their tails like a comet. So they have been named after the mythological creature centaur, which is a mix of horse and a human. So astronomers propose that there are at least 50,000 to 10 million centaurs present in the outer solar system, which are of kilometer size scales. And since their discovery in 1927, only 18 centaurs have been found to be showing some kind of activity. And one of them is Centaur 2014 OG392. And shown here in the right side is an image from Lowell Discovery Telescope. So you can clearly see the core of the centaur and its diffuse coma or tail-like structure. So the coma is extending up to 400,000 kilometers. So this activity associated with the centaur is thought to be sublimation processes of carbon monoxide or ammonia. So this large-scale activity associated with 2014 OG392 has forced astronomers to reclassify this centaur as a comet. Next news is about the detection of cyclopropanyl molecule in the atmosphere of Titan. So Titan is one of the largest moons in the solar system, and it's the largest moon of Saturn. It's particularly interesting because Titan is the only moon having a dense atmosphere in a solar system. So its atmosphere mainly comprises of nitrogen, methane, ethane, and hydrogen. It is having a rocky core and an ice crust, but it is also believed to have ammonia-rich liquid water in its subsurface. So Atacama Large Millimeter Array spectroscopic observations towards Titan has led to the detection of this particular molecule, the C3H2 molecule. So why this is important? Because cyclopropanyl is not a common molecule. It has been detected only in few of the gas clouds in our Milky Way. such as the Taurus molecular cloud, and it's the first time that it is detected in an atmosphere. And this is the only cyclic molecule other than benzene discovered in Titan. Such cyclic molecules are really, really important because they are crucial for the formation of biological molecules like RNA and DNA. So astrochemical studies towards Titan is really important because it's a real-life laboratory to observe the chemical activity similar to that prevailed in ancient Earth. Next is something about detection or the confirmation of water on lunar surface by SOFIA. SOFIA is the Stratospheric Observatory for Infrared Astronomy. It's a NASA's flying observatory, and it uses American-German aircraft. And it's the first time confirmation of water molecule on sunlit surface of the moon. So the observations were carried out using SOFIA faint object infrared array camera, and water molecule has been detected near the Clavius crater, which is the largest crater, one of the largest crater in moon. So previously, many facilities have detected signature of water, but it was not confirmed. They have identified infrared absorption lines, which can be attributed to either water or hydroxyl molecule. But with SOFIA, they were clearly able to identify a 6 micrometer emission line, which is a clear signature of water. So this is completely surprising and challenges our understanding of lunar surface, because previously it has been thought that water molecule is present only towards the colder regions of lunar surface. But now it's detected in sunlit side as well. So it's believed that maybe the water molecules are either hidden between the grains or on the surface, or it's present in a bead-like structure. So it's shadowed from the harsh sunlight. So LIGO-Virgo collaboration has announced 39 new gravitational wave signals. So in their third observing run, this is pretty exciting because in the last 2 observational runs, they have detected only 11 events, but now it's more than quadrupled detection in last 6 months, which make the total events to be 50. So the new surge in this detection is attributed to 60% improvement in the detector sensitivity, as well as more operation time without any interruption. So this many number of new gravitational wave events will provide astronomers a plethora of data to work with, which will give important clues towards understanding the merger events. So before winding up, I would like to present a beautiful image of the Skull Nebula, also known as NGC 246. So taken with the Very Large Telescope of European Southern Observatory. So they released this image last week. So this is a planetary nebula, which is located at a distance of 1,600 light years. And you can clearly see the central white dwarf in the image. And this white dwarf also has a binary companion star, which is not visible in the image. But also the binary is orbited by a third outer star. So this is the first non-planetary nebula with a triple stellar system at its center. This nebula is also known as the Pac-Man Nebula by some astronomers because of its similarity with this Pac-Man game structure. So if you are interested to read more about these discoveries, you can have a look at the links given below here. And I would also like to announce that our next AOT Cologne event will be in February next year. So we will update about the details of the next event in our social media pages. So do visit our Instagram and Facebook pages for more information. With that, I will stop and thank you.
Thanks a lot, Veena, for the really nice update on what has been up in astronomy and seems to be quite a lot. And yeah, I think to end with the Skull Nebula is also a great note, since it also corresponds to what Dori was showing to us in her talks. So thanks to all our viewers who have been watching. And then if there's anything else, right, we will answer. If not, again, thanks to you all. Thanks to Dori. Thanks to Veena. And we will end this session here.